Good afternoon, everyone. Caresoft Technology would like to welcome you to our Cloudflare webinar, Smarter Load Balancing for Modern Apps. At this time, I would like to introduce our speakers for today. Steve Carlson, Senior Strategic Solutions Engineer at Cloudflare, and our moderator, Matthew Bachnovitz, Senior Strategic Solutions Engineer at Cloudflare. Steve, I'll pass it on to you. The floor is all yours.
Okay, great. Let me share this really quickly here. All right, can you guys see that okay?
Looks great.
All right. So thanks for attending the webinar today. Um, we are going to be covering smarter load balancing for modern distributed applications. But before we get going, I did want to kind of expand a little bit on the term load balancing. Now, obviously, we have to use load balancing as a term in order to be aligned with competition and some of the other products that are out there. But I did want to kind of throw out there that I prefer personally the term traffic management or traffic steering. So as we kind of go through this, I'd really like you guys to think to yourself about the concepts of traffic management. But obviously, we'll be referring to load balancing and traffic management kind of interchangeably. But I just wanted to kind of throw that out there so you're thinking about concepts of traffic management, right? So a short agenda here, and I also did want to point out if you got some questions, Matt will be addressing those in the chat, and then we'll leave some time in the end to answer some questions. But quick agenda here. What is the current state of load balancing? What are some of the issues with the way that it's currently architected and sold and used? Some solutions as to how some people are trying to solve for those issues, and then how really what's needed is a much more modern, updated approach to solving those problems, and then how Cloudflare can not only solve those problems, but offer so much more. And in the end, we'll wrap this up with how you guys move forward, how you contact people for more information, and then some additional time for questions at the end. So first things first, let's take a little bit of a step back, and I'm going to set up a little bit of a scenario here for you. So this is a fictional company that has a new modern distributed app that they're trying to deploy, right? And so we've got some users on the left-hand side here. I've just picked some random cities in the US, and obviously you could have people in different locations, or maybe you have a concentration of users in one location, but I did want to account for remote work and everything else like that. So I picked Sacramento, Atlanta, and Dallas as just representative locations where people could be. On the company side, we've got three major locations here. We've got the headquarters, which is in San Jose, California. We've got a cloud provider that they use, so a hyperscaler where they have some resources. And then they've got a co-location facility in New York, New York, where they also have resources that they host. And so most of the IT infrastructure for this company is centralized in San Jose at their main headquarters, but they also offload workload to these other two providers at times, right? One thing I do want to notice is, I want you guys to notice is in this old kind of architecture, there's licensing across all these load balancers. So there's the primary load balancers, which are hardware in San Jose. There's licenses on the hardware, there's licenses on the software, and there's maintenance on that. There's licenses on the virtual load balancers as they sit in the cloud provider's environment, and there's licenses for the virtual load balancer set that's in the New York co-location facility. And there's also licenses around accessing those services for the users. So basically licensing all the way around. And as we all know, licensing doesn't get any cheaper. It only gets more expensive. And they're paying anywhere from 5 to 20% every year to maintain the exact same functionality that they've originally purchased their original architecture for, right? So say this company wants to deploy this new distributed modern application. So essentially, they're going to be placing that predominantly in San Jose. The hardware primary load balancers are going to be fronting that application. So initially, the customers are all going to go to San Jose and request the services for this brand new application. Now, obviously, the servers in San Jose can respond to that application, but because it's a modern distributed application, they've spread resources for that application across the other two data centers in order to accommodate load and performance and everything else like that. So this load balancer has to reach out and confirm the availability of those resources and kind of add that to the overall vision of the application and what services it has to return, right? If any of those resources are coming from those other two data centers, those have to go back to that primary load balancer, and that load balancer has to deliver the application in its entirety back to the users. So I think this is pretty obvious to point out the flaw in this general traffic pattern. So this is a hairpin where a lot of the traffic is coming in and out of the primary load balancers and their communication to the other offloaded load balancers. But ultimately, there's somewhat of a single point of failure in the primary set of load balancers in San Jose, but also this aggregation that has to occur for the application to kind of get reassembled and then represented back to the users. So this kind of results in a lack of performance for the users. This is all kind of self-inflicted, and essentially the users get less performance and less efficiency than they should be getting. Right. So how do we solve for some of these problems? How do we kind of mitigate this? I have a lot of customers that say, "Oh, you know what? We need to reduce our licensing. We need to reduce complexity. We need to improve efficiency. So let's move this to a cloud-based um, cloud provider product," right? So essentially, in this scenario, let's say that we moved this to the load balancing primary functionalities to the Ashburn, Virginia cloud data center, which is a cloud service provider hyperscaler, right? So we're going to use their product for load balancing, and we're going to start sending traffic through this Ashburn, Virginia cloud data center, right? So obviously they've offloaded the hardware from San Jose, so they may not have the hardware costs that they're incurring in San Jose anymore, but they still do have licensing unless they moved all of these resources to the cloud vendor, which generally isn't realistic. They still have to have some licensing for these other nodes and these other data centers because cloud products generally can't see anything outside of their own infrastructure in order to send traffic or load balance it, right? But that being said, I don't want to get too complicated here, but these users are now going to the cloud data center to try to get this modern distributed application. And essentially, that load balancer is reaching out to the other two nodes to get assets or resources, et cetera, that it needs, and then pulling that back into this data center and sending it back out to the users. So I think this is pretty obvious that yes, you may have offloaded some of the hardware costs in your headquarters and some of the licensing costs for this scenario, but you haven't improved, maybe except for scalability in the cloud data center, you haven't really improved the experience for the users at all. They're still kind of hairpinning through the same process and having the same thing happen. You're just moving resources to someone else's data center in this scenario, right? On top of all this, you're also adding usage-based costs to this. So most cloud load balancers charge by query. Most cloud resources have charges based on egress fees. So as you're shuttling data back and forth between these other data centers and using this usage-based service that's in the cloud service, you're actually ticking up usage-based costs. And in a lot of cases, a lot of people know cloud services aren't necessarily cheaper. They could be more expensive than the original architecture and the way that you were paying for it before, right? So how do we solve for this, right? So like I said earlier, and I keep repeating this, modern distributed applications that are designed to run across hybrid environments, they need something that's a little bit more modern and a little bit more smart about how it distributes traffic and how it gets its job done, right? So Cloudflare has spent the last 14 years building one of the world's largest and fastest Anycast networks. And what we have over 300 cities where we have our points of presence. And most of these cities are multi-data centers. So we have over 550 data centers that represent our massive Anycast network. And so the whole idea around Cloudflare is that we can connect your resources and users to Cloudflare's network as a hub for all of the aggregation of that traffic, right? So we call this the connectivity cloud. And the connectivity cloud's job is to make sure that your users and your resources are connected and protected. And on top of this network, we've added all of our services. So we do all of our services at every point of presence in every city and every data center around the world, right? So that includes our load balancing and traffic management. So the idea here is that you connect your assets, whether those be your application assets or your users, to Cloudflare. And you connect to those resources in the same place that you're at. So if your users in Sacramento, you're connecting to Sacramento. That's where they connect to Cloudflare. If your users in Atlanta, you connect to Atlanta, and that's where they connect. But also your resources, your server resources, and your application resources, they connect where they're at. So San Jose connects to San Jose, Ashburn connects to Ashburn, and New York connects to New York, right? Then Cloudflare actually manages the traffic in between those connections based on the platform and its policies, right? So if a user in Sacramento or Atlanta or Dallas requests resources to any of these nodes, policy and governance in the middle tells it exactly where to send that traffic and how to get that traffic back to them. So as you guys can see, this is a much more efficient way of doing things, right? We're not sending all traffic to one location and distributing that out. Every request is evaluated on its own merits. Every response from the application is evaluated on its requirements and its own merits, and those two things are tied together on our connectivity cloud and efficiently distributed back to those users. Not only does your server infrastructure, your application infrastructure see a much more optimized and efficient traffic pattern, it's not getting queried for things that it doesn't have or doesn't know about, but your users also get reduced latency by connecting locally, improved performance, improved response, and so their user experience gets better in this whole process. So to summarize, you guys have better user experience, better server efficiency, less resources needed, etc. Now, on top of this, like I said a little bit earlier, we have added every single service that we offer on top of this massive Anycast network. So essentially, we can add everything else, including security and access policy on top of this. So not only can you distribute the modern distributed application efficiently, but you can control access to that modern application. So you can actually set policy on whether or not the users can get to the application at all, or even certain aspects of the application. And at the same time, you can enforce security policy on that to make sure that bad agents don't get to the application or that, bots or anything from a user that's been compromised can't get to the application itself either. So all those services you can enable and just turn on inside the platform. It's as simple as just enabling them and configuring them and turning them off and disabling them if you don't need them. So ultimate flexibility inside of this environment. Now, what if you don't have a modern distributed application and you just want to do something simple like disaster recovery, right? So a lot of our customers have long-standing disaster recovery requirements and projects that they just struggle with getting done. So with Cloudflare, the same concept applies to even simple disaster recovery and the application of traffic management. So say instead of a distributed application, you have just copies of your application that you sent out to different locations, right? So in San Jose, you have application copy one. In Ashburn, Virginia, you have application copy two. And in New York, you have application copy three. The same thing can be done. Traffic management and load balancing can be applied to govern who gets access and what governs which replica gets access when needed, right? So that can be anything, policy can be anything from just pure availability to number of connections, bandwidth consumption, anything else like that that you want to set as a policy where it evaluates where to send the traffic and how. And even in the case of maintenance, say you have the copy of the application in San Jose that needs to be maintained. Maybe there's a CVE that got released and you need to patch it. Maybe there's something else like an upgrade that you need to apply. The system automatically will account for the fact that you've taken down the server in San Jose. None of the users will be interrupted or unavailable to access the application because they'll just automatically fail over to Ashburn or New York. And then when that server comes back up and gets re-added back into the policy, it will move that traffic back to the primary or wherever it is that you've defined is the right place for that traffic to go. So instantaneously, you have a solution for disaster recovery, the ability to keep providing the services that are so critical to you and your constituents, and essentially you can be successful in those disaster recovery projects, right? And the cool thing about this is that expanding on this or adding a copy or adding a node to your modern application is as simple as just connecting it to Cloudflare. Once you connect it to Cloudflare in the same way you've connected your other assets or your other replicas, adding it to the policy is trivial, and having it spread to that existing expansion is as simple as just adding it to the policy and updating the policy. Again, the users have no idea that that's changed. They just get better performance, they get better availability, and everything just improves from that. The one thing I also wanted to add is we work on a subscription model. So our platform is a subscription. We realize that most organizations have the requirement for fixed budgets. And so you guys need a very predictable, plannable budget item that you can plan for and that you can put into your budgets and request approval for. So everything's subscription based. We don't charge for oversubscription. Essentially, if you go over the subscription that you've paid for, we get a notice and we will work with you on when the appropriate time to expand that is. And so this is much different than other licensing models where you have unpredictability, particularly in the cloud usage-based model, where if there's a spike in traffic, you could get an unexpected spike in cost. That won't happen with Cloudflare because of the subscription model. So you can keep everything very predictable and repeatable year over year. And we do support multi-year contracts. So again, this is Cloudflare and Cloudflare's connectivity cloud. It is essentially our entire platform that runs across all of our entire massive Anycast network. So we have the ability to connect users, networks, applications, and clouds globally. We have the ability to protect those resources that are connected to Cloudflare. So that's your data, your apps, your infrastructure, and your users from anywhere. And that we allow you to build really modern, innovative digital services and experiences that really match your requirements for your modern applications and your modern requirements, right? Cloudflare is constantly expanding its network. We currently have almost 400 terabits of edge capacity, and every time we add a pop, that goes up. So I have a really hard time keeping up with it. But essentially, our network is always getting larger and faster. And that means by default, you guys are always getting better and better performance as we improve our own connectivity cloud and make it better for you. So that's really all I have for today. We do have a couple things I wanted to point out here. Definitely, if you want to get in contact with us, we have this email address, publicsector@cloudflare.com. So any sort of information that you want to get, you can email us there. We also want you to know that we are always available for you if you are under attack. So if your websites are being bludgeoned by bots, if your websites are being attacked, or if they're being overwhelmed, or you see that AI has really hampered the performance of your websites, you can always call us at this cyber emergency hotline. And essentially, we'll step in and step in front of that traffic and help offload that for you so that you have time to mitigate what's going on. So that's a free service for us. We don't ask for any sort of money up front to do that. And I just wanted you guys to be aware that if you're ever in trouble, we have an entire team of engineers standing by to help you mitigate it in any way that we possibly can. And then we can talk about what services you want to maintain or keep later. We want to get you help first. So that's pretty much all I have. Anna, I don't know if you want to move over to some question and answering or some final wrap-up questions.
Hey Steve, we have a question in the QA, and I think it might be worthwhile to answer this right away.
Okay.
Questions from Brian, and I see the advantage for internet facing web servers. What about SASE and VPN networks?
So SASE and VPN networks, we do also have the ability to connect to your private networks. And so we do have a different collection of what I like to call connectors. And so we can connect to your private environments. We do have a full SASE suite of products that go along with that as well. But if we can, we really do play well with others. So once we are connected to your private networks, we can also traffic manage different paths and different directions for both internal and external load balancing. So we do have solutions for that.
Yeah, and I'll add to that and say, like for our SaaS solutions, it's all a lot of the same advantages. We really mean it when we say we serve all our services everywhere. All your users are connecting to a local POP, and that reduces latency a great deal and really helps us route traffic in a really efficient manner. So when you look at our SaaS solutions, they're very performative.
Mhm. Yeah, and I think that's really the differentiator between us and everyone else. We actually own our own network. So a lot of other, even the hyperscalers, they don't entirely own their own networks. So we made a decision very early on that we were going to build our own network and own our own network, and then therefore be able to optimize and manage that traffic exclusively for our customers. So I think that's a huge advantage to the ability to perform is that we have unique visibility on the traffic, unique policy that applies to that visibility, and the network to back it. Any other questions, Matt?
Nope, no other questions on the Q&A.
Thank you,
All
Steve
right.
and Matt. I want to thank all of our participants as well as our speakers for being with us today. We hope our webinar has been helpful for you and your organization. If you have any further questions or would like to request more information, please feel free to contact us. Thank you again for attending.